We have an r squared and an r. We can now solve for r. I'm going to get r on this side and everything else over there. So I have negative n negative n squared h of r squared times 8 pi epsilon sub naught. So moving this over that way. Positive. The negatives cancel out. And over on the left here, I got on the bottom, I got 2 mass of the electron times e squared, bringing this down. And that's equal to r. Multiply both sides by r squared, and one of the r's cancels out. Writing this slightly differently, h bar squared. So I have 4 pi h bar squared epsilon sub naught over mass of the electron times e squared times n squared is equal to r. Remember that n is some number 1, 2, 3, 4, and so forth. And so we now have a formula for the radii. And so let's actually figure out what this is right here, because that's just a bunch of constants. So 4 pi times h bar squared times epsilon sub naught, just another constant, 8.85 times 10 to the negative 12. That would be Coulomb squared per Newton meter squared. Yep. Divided by the mass of the electron times the charge squared. The mass of the electron, 9.11 times 10 to the negative 31st kilograms. And the charge of an electron, this is not E as in Euler's number. This is 1.6 times 10 to the negative 19 coulombs. So if you multiply all that out, okay.
I got 5.303 times 10 to the negative 5th.
5.303 times 10 to the negative 5th.
Yes. Anybody?
Yeah.
Yeah.
That's a 5 there. And did I?
No, I just wrote a sub 0.
I did. That's good. It's not confirmation. What would the units be?
Oh boy. Oh, that's a mess up there.
Because ultimately it comes from this formula right here. Again, while Alex is working through the math to get confirmation, what are the units?
Dr. Frost, what's the unit of the E 1.6 times 10 negative?
Of this?
Yes.
Coulombs.
Coulombs. Okay. Is it the same with the C in the epsilon?
Yeah, that's a Coulomb also. So the question on the floor, Holden, Alex is confirming what Aaron did, and the question is, what are the units of this? What I've circled right here, what are the units?
The units, Joule square times second square times Coulomb over,
That's a joule second squared coulomb, is that what you said?
Joule square times second square times coulomb over
You did to the power.
Newton times meter square times kilogram.
I was trying to figure out where the destructive.
Something's off there,
Hit, alpha, and then.
because epsilon has a coulomb squared, and this E is squared, so coulomb should have canceled out.
Oh, coulombs cancel out.
Wow, that's big.
Can we start?
You got a huge negative number, or a very small number? Is it
Squared
or
or second squared over Newton over meter squared times kilogram.
So you did joule squared, coulomb squared, Newton, meter squared, kilograms. Coulombs get canceled out.
Look at all of them.
Oh.
Something's off.
Make sure you use plenty of parentheses, because these things are hateful.
You got something different?
We're working on it.
Yeah, I
Okay.
got something wrong here.
Make sure I didn't write something down wrong. So 4 pi epsilon sub naught h bar squared over n e squared, so we're good on that. So what Kong did was basically go straight with dimensional analysis. So you had the h bar squared, which would be joule seconds squared.
That's,
Epsilon sub naught coulomb squared over Newton meter squared.
ME is a kilogram.
That's right. So it's kilograms and then coulomb squared.
Right.
Oh, okay, I realized one of my issues. All right, so a joule is a kilogram meter squared per second squared times seconds squared, that's squared. Coulomb squared over Newton meter squared kilogram coulomb squared. So just basically brought this down here and expanded joule.
no, 5.3.
Oh, they're still working on that. Coulomb squared cancels out. We had,
Some of those seconds are gonna cancel out, aren't they?
this second squared though is squared.
Oh,
So we have a kilogram squared meters to the fourth over seconds to the fourth times seconds squared
right, okay.
over
4
Newton
pi is something.
meter squared kilograms.
Should I, does it matter?
It probably does.
So that cancels out with 2 of
Our
those.
number's the
Right.
same, it's just the.
That cancels out with 2 of those. That cancels out with 1 of those.
Yeah.
And so what we're left with is a kilogram meter squared per second squared divided by a Newton.
So, everything except the meter. So, yeah, it's, okay, the meter, which would make sense because it's radius.
Yeah. R is a distance here, so, and N is just a number, so this better be meters.
What threw me off is that A says 0.
Oh, that?
Yeah,
Oh, that's just the letter that's traditionally used for this.
okay.
It's called the Bohr radius.
That's
It's ME, oh,
oddly, like, close to being visible.
yep, alright, we gotta,
Well, we'll find out.
it's the same number except it's to the negative 11th.
That makes more sense.
Okay.
Yeah, it makes a whole lot more sense.
Yeah, because you're,
That's like a little bit less than a millimeter, which,
yeah, we can measure stuff, we have instruments here that
Yeah.
can measure things that, what the original number was, meters. All right. Thank you for working that out. All right, so what we have here, what Bohr's come up with is that this radius of an electron's orbit is equal to this Bohr's what is called Bohr radius, times n squared. So r is going to be equal to a sub naught, or if n is 2, 4a sub naught, or 9a sub naught, and so on. Now, what he's done is speculated that we now have these discrete orbits with very specific radiuses, radii. The next step is, how does this match prediction? Or how can we actually test this? Well, part of this is that when the electron moves from one level to the next, from one radius to another radius, it is either has to absorb light or emit light. Well, we can pump energy into it. We really can't see what energy is absorbed, but we can see what happens when it's emitted. If I throw energy into an atom, again, not so much as to eject the electron, but I throw it in there, the electron goes to another level, it's not stable there because naturally it doesn't hang out there, and when it collapses down to a lower level, it will emit light. So we need to figure out when it goes from, say, here to here, what is the energy of the light that is emitted? Because, in other words, how much energy did the electron lose? Well, back over here, I know that the energy is equal to negative E squared over 4 pi epsilon sub naught times R. I have a formula for R now. This is equal to negative E squared over 4 pi epsilon sub naught A sub naught, which is that 5.303 times 10 to the negative 11 times 1 over n squared. And so we have this new constant here, this negative E squared, the charge of the electron squared, over 4 pi epsilon sub 0 times A sub 0. And so the question is, what is that equal?
Is that Bohr radius a constant? The 5.303?
Yeah, that is.
Okay.
So that E right there is the 1.6 times 10 to the negative 19th, the epsilon sub naught, the 8.85, etc. And the A sub 0 is the number that they just came up with.
What under that, 1 over n squared in that formula, it just seems like it,
Say
that
again?
1 over n squared, it seems like it disappeared.
Oh, the formula for energy is this. I'm just looking, and then I just
Oh.
rewrote the coefficient.
Okay.
Really? I got a number, but I feel like it's doesn't make any sense.
What'd you get?
Negative 27.13.
Yeah, that doesn't seem right.
Doesn't seem to make any sense. Oh, I forgot to square that, the E on top. That would do it.
That's a good point, because that's just square that as well.
There we go.
What do you got now?
Negative 4.34 instead of the negative 18.
Negative 5.
Yeah, that's what I got.
That's the same thing.
Seems like I positive 4. I'm
Well,
just negative 7.
Okay, I'm getting.
The negative comes from this negative that's sitting right there.
Yeah.
Oh, yeah. I mean, I put that negative in here.
And that is different than the number I've written down here.
That's what I got as well.
So therefore,
Is our A right? Is that-
handle that. Alright, look at that.
Rather than that record. Who's using the mouse and not just like for the rest?
Yeah, exactly.
My glasses are fogging up.
This mouse is good.
Oh, whoa.
I need that little band usually, but for some reason this one is so bad.
Yeah, the glasses are good.
Oh. Squared. Alright, so. Oh, what? Why don't we officially take a break here? Instead of staring at me doing this.
There's a big sale on you, yeah.
Don't say that. You wanna have one?
What's your RAM that looks like?
That's-
5,000.
So that would be joules.
You know what I like to do? I like to price gouge.
I bought it, that monitor that I bought.
Buy all the CPUs.
Yeah, and buy all of them.
Yeah. I'm taking our business on.
That monitor I got it, the $699 one, I got it for $200 off.
What is it? Is it 4K?
It's 1440p, but
Okay.
it's 240 hertz.
Yeah.
See. What about 4K at 30?
30.
And like 100 milliseconds of interplay. That's what I used. Except it was.
See my video I sent you on Discord? No. I finally did it on channel one,
Oh yeah, I think I replied.
but then I'm back down with that.
Oh no, I didn't. Did you get
No.
the words?
Yeah.
Nice.
Verdict?
Stupid code edit mistake on my part.
That'll do it.
Yeah.
We can play some time if you want to.
Oh,
It's fine. I play, like, I have a real life friend. My best real life friend is in Diamond.
Me and him would probably be a good matchup.
Probably, yeah. He doesn't play at Diamond.
So something.
Energy, it's an 8 on the bottom, not a 4.
Oh,
Which means it's, so basically it's half of what you guys have.
do we need to change our A naught value?
No,
Okay.
no, 8 not's fine, cause I had the 8 mixed in there, it was just when I rewrote it over there. I'm so used to 4 pi epsilon naught that it went into autopilot.
I'm trying to figure out what I put in my calculator that doesn't make it negative.
You just have to put the negative way out front of the fraction bar.
Okay, so, don't put it with E, like I said.
Yeah, I tried putting it with E and it wouldn't change it either. Cause the value is squared.
Yeah, that's true, that makes sense.
I think if you put it out in front of the value, it might work, but definitely in front of the fraction works.
It definitely does work that way.
So I got 2 point, yeah.
Yeah, I got what you got.
That should just be half of what you guys said.
That's an extremely small number.
Wait until you hit champ 3. I'm so excited for that. All of my free time,
Yeah, we'll
I
make sure
spend
the exact same
playing
thing.
champ 3s.
That's what Bohr was champion, but then I think the strength team, they don't have, like, I don't know, how are y'all here?
Champ 3 is,
Yeah.
I should be grand champ, but they don't know what they're doing.
I haven't tried, but I can't wait to fix the ranks or whatever, but yes. Probably not necessary.
They changed up the way the threshold works. So your MMR, it doesn't change, but they change where the ranks are placed at MMR. So your number of skill level is the same, but the ranks.
They changed the range pretty much, yeah, I believe. Yeah, it's something, it feels like I've played like 4 games in a row, and I lose 1 game, and then I just.
Yeah, once you start to get into the champ area, it loses. The higher you get, the more a loss counts against you, and the less a win counts for you.
Yeah, like. Oh, and I'll try to play another tournament, so I'll get a season 3 tournament one. And. That was rough. I'm over here just circling my half of the field,